Alright, welcome back. So we've got another interesting example here, so we're just going to work on that. Now this is asking about this path. When is this distance minimized to this point? So this is our distance here. So when is that minimized? And of course our distance formula is the Pythagoras version point form. So we have x minus x1 all squared plus y minus y1 all squared. Now in this case here, our second set is the origin coordinates 0, 0. So they're our second set. So when we come to populate this, it will be x minus 0, y minus 0 all squared. So that's our version because we're dealing with the origin. So that kind of simplifies it in one way. Alright, the next thing we want to recognise is that the x minus 0 resolve to just x squared. And finally, the y that we're using is this y up here. Okay, so that y is going to be inserted inside. And so we'll end up with 3x squared minus 2 all squared as part of the square root. And finally, the thing that we've got to do a bit of pre-work for calculus is that we've got our d with respect to x now. So we'll just notice that we change the y out. So we've got a function, so we can use our calculus ideas. And we've got x squared plus our other points, which resolve the 0. Just not interested. And so we've got a half. Alright, so now we can work on a derivative. A derivative for this guy. So the derivative will be interesting because there's a fair bit in it. So we've got the derivative of the distance with respect to x needs to be set to 0. So we need to work out the derivative with respect to 0. So we'll just go ahead and make that derivative. Alright, so what we'll have is we're going to d dx everything inside the brackets. So we're going to have to split this up into a couple of chain rules. Okay, so we'll do that. We'll do them the long way. So we'll let u be everything inside. So I might give a bit more room for that. So everything inside. And that means that we'll be doing a du of u to the half. So that's a straight one. So that'll be chiming in here. Now du dx has a problem in that we need to do a further chain rule on here. So if we do d du dx here, we've got the sum term, which is fine with respect to x. But we're also going to have to sum a d dx of this one. So now that's just in expression form. So we're going to let m equal the insides of that. So the m dx chain together with now d dm of m squared. Okay, so they'll chain together. So we've got a few things going on here. This is a composite part. Because of this x squared, u dx has got 2 bits to it. So I've only broken out the second part as a second chain. So this is a little bit complicated. Alright, so 6x is the derivative of this one. This one becomes 2m. They chain together to become 2, 3x squared minus 2, 6x. And I'm just going to leave that nugget as the ddx of this part. So that's the chain rule for this part only. So that's, if you like, the answer to that one. Okay? So that's going down, that's the answer of that one. Now, the du dx of this is 2x, and we've also got to do this one. So that's up and under. So half comes out the front. Half minus 1, I said the wrong thing there. So it'll be the square root of u. So we're going to get this chain together with this, and that is a sum term. So what we'll end up with is a d dash of all of these parts together, summed with x squared. So we'll get, I just want to move that up a little bit. Move that up a little bit. Put the distance formula with respect to x will be 1 over 2 times the square root of everything that was u, just this rather long part here that was inside the square root sign. So there's a fair bit there. Squared. Then that's being multiplied by, so that's this part now, x squared plus 2 outside of 3x squared minus 2, 6x. That's the other part. Right, so they all go together. So this becomes, putting this on top, now we're doing any expansions at the moment, I might just put them on top. Now that part there also had to be ddx, didn't it? Nearly forgot that. So that part there is 2x, so it's also part of the sum term. So that's actually 2x, not x squared. So I do apologise for that. So I caught that one just in time. So that was that one. So the x squared term's still there from this, but that had to be ddx, and that had to be ddx. Okay. Alright, so we've got our sum terms, so we can put them across as 2x plus 2 outside of the bracket squared minus 2 times 6x all over 2 Now you'll notice that the 2 appears in the algebraic term here and here. So we can bring that out as a common factor and it'll cancel the denominator. So just a bit more algebra. It's pointless doing this kind of thing if you don't know how it's developed, so that's why I'm spending the time. So we'll bring the 2 out and we'll end up with x plus 6x, just bring it to the front, over to the square root. So they'll cancel. They'll cancel, and we'll be left with, now we can do this expansion on the numerator. So we'll get, 18x cubed minus 12x So we'll do that expansion. So we'll have x plus 6 3 is 18 x cubed minus 12x over just now the square root. So just being patient and putting all in calculus is not the problem. Now, apple plus an apple. So the final result we're going to get is going to be, I'll put it here, 18x cubed minus 11x over so that's our final derivative. Okay, so that's a lot. That's a lot right there. So that term. All right, now the question then becomes, when is d dash of x equal to 0? So we have to solve this quotient, okay? And that'll tell us some points where it's 0. So if we take, we multiply through by the bottom, that'll get rid of the thing there. So all we're checking then is 18x cubed minus 11x equals 0, which will fashion itself this way as 18x squared minus 11 equals 0. So we know we have to take some care now. So therefore, x will be 0. This is true when this one's 0. And it will also be true when 18x squared minus 11 is 0. So 18x squared minus 11 is 0. A bit of undo. And so we know we undo on both sides. So we get x is equal to plus or minus the square root of 11 over 18. So at those points we're going to have mins. Okay, and we need to just check this now because we've got our interval. Let's just check our interval. We know that one of the values is 0, so that should be fine. We also know that we've got another value of minus square root of 11 over 18, and also a plus square root of 11 over 18. Now we need to check some values. 11 over 18. So we need to see if the sign changes. So x is approximating here to 0.8 plus or minus. So 0.8, that's a pretty small value. So we need to check at a half. We need to see what's happening at a half. We need to see what's happening at positive a half. That's 0.8, so we need to check 1. And we also need to check the other one, because we want to be sure that it is actually changing. Because we know at these points, we know the derivative is 0 here at these points. We know the derivative is 0, so we know there's a a flat point there, and we know there's a flat point there, and we think there's a flat point there, but in between these we need to have changes of direction. Okay, so if we check our value, so -1 or any other value, -1 would be -18. Now that would minus times minus is a plus, so -18 plus 11 is still -7. So -7 gives you a big negative for this one, tick. So that's as we hoped. So it's decreasing. This is a minimum then, perhaps. Minimum, decreasing to a minimum. Let's check it though. We need to check a half. So negative a half. What's a negative a half going to give us? It will remain, so it'll be 9. But minus times a minus is a plus. So you're going to end up with 11 on 2, which is what? 6 and a bit. This was 9. So 6 minus 9 is a positive. Great. So we got to change. Fantastic. So that's a min. That's going decreasing, increasing. That's what that bit's doing. Fantastic. So that's a min. Just by checking, because I mean, if we're going to find we can find the second derivative and work that out. Okay. All right. So what else have we got? Half. Well, the half will be 9. That'll be -9, minus 11 on 2. So again, we're going to have a minus. So that's good. So this plus leading up, and that means that's a max. So it's increasing to a 0 and then coming to a minus. So this is a max. Very good. And then for this one, 1. So 18 minus 11 is a positive. So we've got a change of sign yet again. So this means this is a min. So it's a very complicated way, I understand that, of checking, but we need to check these functions as they come out to us. Okay? All right. Now, what was the other thing in the question? Provide an exact use count to determine the closest distance. So we've actually got to do a calculation at this minimum values. Okay, so which one's going to be the minimal? So it doesn't matter. We can just do root on 18. So it's a little bit complicated, but we have to go back to our distance equation and root 11 on 18. So we're going to go, we'll check the minus, because it will be the same value, won't it? I think. So we'll get to square root minus the square root of 11 squared plus 3 times 18 squared minus 2. That's all squared, isn't it? So that's why we needed that front bracket. Okay. So then we'll get that should be equal also to the square root of 11, 18. Just noticing the 11, 18s squared gets rid of the square root sign, undo. So we get same family, 18, 2 18s are 36. That is 33 minus 36. So even though it's a minus 3. It's a minus 3 overall. Because of this square, that minus 3 is going to become a positive 9. And the 18 on the bottom will be squared. Okay, 18 squared. And that'll give us, so if we multiply both sides by 18 squared, get 198 plus 9. Make them the same family. Yes, I know it's a lot, but it asks for an exact value. Okay, so we've got to keep going with that. Which is the square root of 207 over 18 squared. Which is the square root of 207. We're doing out. It's all algebra, isn't it? Just doing lots and lots of that. So products of 27 that might be divisible, maybe 9. So that would be 9 times 23. So just using the skills that we've gained in algebra. So the square root of 9, that can be split into a product. 23 will stay. The square root of 9 is 3. So it'll be 3 root 23 over 18. Now they'll cancel. 3 goes into itself once, and it goes into 18 6 times. So this would be 23 on 6. So that's your exact value answer, and that approximates to 0.8. But it asked us as a direct answer. All right. So that's our distance. So its minimized distance is 0.8. So that's it. We got there. All right. I'll be back. Thank you.